Yeah, can we go ahead? Can we go ahead? Yeah, TOC class 2. Yesterday class 1 over, now class 2. TOC class 2. Can we go ahead? Yeah, let's start now. Let's start now. TOC class 2. Let's start now. So if you see yesterday we started we started this particular subject yesterday. TOC subject we started. So this is the marks distribution. Yeah, if anyone not seen yesterday's class, please go through it. So just I done the syllabus and marks distribution and total gate CSC. Total gate CSC marks distribution also I done. This is the total gate CSC marks distribution. Right. Next one is it is the introduction. Right. Introduction of the subject. So in TOC mostly we'll discuss about formal languages. TOC mostly will discuss about formal languages. So I given the definition. It is a collection of strings. Because if it is a language, it is also a collection of strings only. But in formal languages, meaning of the string not important. Format of the string is important. So I think I given so many things. So triple A, triple B. No meaning, but format is 3A's followed by 3B's. A, B, no meaning, but single A followed by single B. Double A, double B. No meaning, but format is double A followed by double B. So like that. So I written so many formal languages. L1 is the formal language, L2 is the formal language, L3 is the formal language, L4 is the formal language, L5 is the formal language. There are 5 formal languages are there, right? A1, A2, and so on, A4. So if you see the L1, these are the strings which will generate. But interesting thing is there is no ending. So it is an infinite language. It is a formal language of infinite size. L2 also formal language of infinite size, and so on. L5 also formal language, infinite size. So I written L6, which is also formal language, but it is a finite formal language. It is a formal language which is of size finite. L7 also formal language of size finite. Next one, types of formal languages. According to Chomsky, we have approximately 4 formal languages. Type 3 to type 0, type 3, type 2, type 1, type 0. Type 3 is the smallest formal language, which is also known as regular language. Right? Like here also, right? If you see India also, according to the way how people will speak, we divided the people into so many parts, right? I think in India, within India itself, if you see, right? So I think the people who are speaking more Hindi people maybe, I think like REL, right? Because in India, many people will speak in Hindi. So REL, that's the type 0. Bigger one is type 0, REL. Maybe smaller one, type 3, that maybe I don't know. The number of people who will speak some small language. In India, different states are having different languages. Maybe some states are having less population speaking in their own native language. So something like that. Type 3 is the smallest formal language. Type 0 is the biggest formal language. Right? There are 4 formal languages according to Noam Chomsky, who is still alive. Right? If you want to meet, you can go and meet. He's there in the MIT. His age is approximately 99 years or 95. You please go through it and verify. Now, if you see the relation between all these formal languages, if you see the relation, type 3 is subset of type 2, type 2 is subset of type 1 is subset of type 0. Ti plus 1 is subset of Ti. Because T3 is the smaller one, T0 is the bigger one. You may say that, sir, what about other than T0? Those are non-REL. So outside I written. It is not required, so I written outside. Outside that big circle, the people who are available outside, they are non-REL. Right? So this is what we done, right? And one more important thing is small formal languages, T3. which are also known as regular. Those are accepted by a machine is known as finite automata. Type 2, which is also known as CFL, context-free languages. Those are accepted by a machine is known as PDA. Type 1, context-sensitive language. Those are accepted by a machine is known as LBA. Type 0, REL, which are accepted by a machine is known as Turing machine. Right, next one. So this is the relation between all the formal languages. Right, yeah, I think until here we done yesterday's class. See you in tomorrow's class. I return. So yeah, I think I already seen. So I am deleting this. I already seen. I'm deleting this. Right. Let's move. I hope everything is fine. We can now concentrate in today about today's class. Yeah. Let me know is audio, video, everything is fine. Is audio, video, everything is fine. Just I done the whatever happened yesterday's class. Just I reiterated again. Whatever happened in the yesterday's class, just I reiterated again. Please let me know. Can we go further? Hello, Rahul. Can we go further? Sunny, I will go further. Sakshi, can we go further? Everyone, can we go further? Hello, can we go further? Yeah, chalo then. Let's start today's class. Let's start. 4 formal languages are there, right? Let's start that. Let's start. So, can you say the date? Today's date. Yeah, let me write. I think it's today is I think 6th to 25. Right? Next, if you observe clearly, yeah. So in my opinion, today's class is just started now. Please be comfortable. Today's class is just started now. Please be comfortable. So let me ask you one small line. Yeah, I think before going to that, I will write. Yes, now see this one. Expressive power of an automata. Expressive power of an automata is equal to number of languages expressive power of an automata is equal to number of languages an automata can accept. Number of languages an automata can accept is known as expressive power of that automata. Number of languages an automata can accept is known as an expressive power of that automata. So this is the expressive power definition. Means simply expressive power of any human. If I take any human, expressive power of any human is nothing but the number of languages he can understand, the number of languages he can speak. Automata means machine. Right? See this one, Turing machine, Turing automata. It is a machine. Expressive power of an automata or expressive power of a machine is nothing but the number of languages an automata can accept, can recognize is known as expressive power of that automata. You can speak how many languages, that is the expressive power of you. I can speak how many languages, that's the expressive power of mine. So I used to see, right? I think when I'm kid, I used to see Indian Prime Minister, Indian former Prime Minister, Mr. P.V. Narasimha Rao, right? So I used to see that I used to read, approximately 10 languages he knows. He knows approximately 10 languages. His expressive power is more in terms of prime ministers. If you compare in the prime minister hierarchy, he is having more expressive power. Other people also having, but we don't know exactly how many languages they know. But as far as right, my brain is concerned, it is remembered that former Prime Minister of India, Mr. P.V. Narasimha Rao, is having more expressive power. Approximately, he knows 10 languages. If you know more languages, you have more expressive power, right? So the number of languages an automata can accept is known as expressive power of that particular automata. I think if you see the above diagram, see this one. If you see the above diagram, bigger automata is Turing machine. Smaller automata is finite automata. Remember, finite automata expressive power. Finite automata expressive power. I think it will accept because of it is a very small, less expressive power. So expressive power is 1. PDA expressive power, because the PDA is bigger than the right finite automata, its expressive power is 2. CSL, right? CSL means LBA, linear bounded automata. Because of it is bigger than the previous two, it is more expressive power 3. Expressive power 3. Turing machine is the bigger one among all. Its expressive power is 4. Some people are asking, sir, you are saying 4. What it will accept, sir? Finite automata will accept T3, type 3 only. But PDA will accept to type 2 also, type 3 also. Next one, LBA will accept to type 1 also, type 2 also, type 3 also. Next one, right? Turing machine will accept to type, right? Type 0, type 1, type 2, type 3. Type 0, type 1, type 2, type 3. Turing machine will accept to type 0 to type 3. LBA will accept to type 1 to type 3. PDA will accept to type 2 to type 3. Finite automata will accept to type 3. Type 3. I hope everyone is fine. So what is expressive power? Simply how many languages an automata can accept, an automata can recognize. How many languages you can speak, that is your expressive power. How many languages I can speak, that is my expressive power. How many languages this automata can recognize. Every machine will accept some language. You take the ATM machine, it is having its own language. If you type in the specific format, then only it will understand. You take any machine, right? Every machine having some capability, some format only it will recognize. So if you take a machine, how many languages it can accept, that is expressive power. We have totally 4 machines. 4 machines expressive power also I written. In terms of expressive power, least expressive power is finite automata, more expressive power is a Turing machine. The reason is Turing machine can accept 4 languages, type 0 to type 3. LBA can accept only 3. So in terms of expressive power, the relation, if you observe, in terms of expressive power, if you see the relation, right, finite automata expressive power is less than PDA expressive power is less than LBA expressive power is less than Turing machine. Actually, it's a less than. If you want, you can keep less than or equal to also, no problem. Less than working, less than or equal to will also work. In some books, you will see less than or equal to also. That is also working. But actually, this is the actual. LBA expressive power less than or equal to Turing machine. Remember, it is not a subset because it is an integer. Finite automata expressive power 1. PDA expressive power is 2. LBA expressive power 3. Turing machine expressive power is 4. They are not subset, they are less than or equal to. But if you see type 3 language is collection of strings. Collection of something is a set. So type 3 is a language which is a collection of strings. Type 3 is subset of type 2 because these are sets, but these are integer. Expressive power is an integer. Type 3 is a sets. Type 3 language contain more strings. Type 3 is subset of type 2. Type 2 is subset of type 1 and so on. I hope you got till now. In terms of expressive power also, I written the relation. If you want, I will write namesake here. Expressive power of finite automata is less than expressive power of PDA is less than expressive power of LBA is less than expressive power of Turing machine. Expressive power of finite automata less than expressive power of PDA less than expressive power of LBA less than expressive power of Turing machine. So this is the relation. Okay, perfectly fine. Until now you are really comfortable. Now let's go to one more small story. One more small story. Try to understand why these many formal languages. Why these many formal languages? Sir, why these many formal languages? Why these many automatas? Why these many formal languages? Why these many automatas? This is the discussion what we are going to discuss now. Why these many formal languages or why these many automatas? Alright, I'm going to explain. So first let's take one formal language. Let's take one formal language. Formal language L1 is equal to a power n, where n is greater than or equal to 1. This is the formal language. This is the formal language L1. L1 is equal to a power n, where n is greater than or equal to 1. If you observe the strings of this particular formal language, if you observe strings A, double A, triple A, 4 A's, and so on, it is accepting any number of A's. Right? So it's a formal language. It is accepting these kind of strings. Now some people are asking, sir, right? Can you draw the finite automata for this? Remember, this formal language accepted by finite automata. Some people are asking, sir, can you draw? You may not get full clarity, but I will give little idea. Remember, automata is collection of states. So let's take state. Circle means state. Circle is nothing but a collection of states. Automata is nothing but a collection of states. State is nothing but, now I am showing in the diagram, state is nothing but a circle. So 2 states I took. Right? So whenever something is a starting state, keep the arrow symbol like this. Whenever something is a final state, keep the double circle. Automata is nothing but a collection of states. Every state we will represent in the form of a circle. So I show starting state. Every machine having starting point. So if you right in the if you see our system also, if you open the computer, right, there is a starting point. You have to log in. As soon as you open, right, you have to log in. There is some starting point. Maybe somewhere you have to on the system. Maybe power button. Every machine having some starting point, and every machine having some ending point also. Something like output. Maybe on the screen you will see output. Maybe on the printer, through printout you will see the output. So in the automata, if you want to say, right, something like accepted, you have to go to final state. So I drawn finite automata, which is a collection of states. I took 2 states. One is initial state. Initial state is represented by arrow symbol. I written the one final state also, final state represented by double circle. But remember, however, in further classes, we are going to discuss detailed explanation about the DFA. Detailed explanation, approximately 30 problems we are going to cover. It is just introduction. Please listen properly. It's just introduction. So write state names also for remembering purpose. Give the state names also. You can give whatever name you like. Let us in the starting state I give an S1. Next state I give an S2. Right now observe. In the language, if you observe, minimal string is A. See this one? And the S1 state, by reading A, I am going to final state. After completion of A, are you in final? Remember everyone, every string should start with starting state. Every string you have to start with starting state. After that string is over, where are you? Are you in final? Accepted. If you are not final, not accepted. See, start the A from the S1 state. S1 on A, string is over. Where are you? Final state. Accepted. Next one, S1, it is a string is double A. S1 on single A, I will go to S2. On S2 single A, once again, so I will go to S2 only. So at the end of the double A, where are you? Final state. At the end of the triple A, where are you? Single A, S1 to S2. At S2, you can keep on repeat. 2 times A also, 3 times also, 4 times also. Keep on repeat. Keep on repeat. So this is the finite automata. This is the finite automata for the given formal language. This is the finite automata for the given formal language. Why these many automatas? Why these many formal languages? You will get to know within a few minutes. I took one formal language. To accept that formal language, I drawn one finite automata. I drawn one finite automata. You're getting? I took one formal language. To accept that formal language, I drawn one finite automata. So if anyone having any doubts, any observations, if you have anything you want to say to me, you can go ahead. Before moving to the next one, you can say to me. Please let me know if anyone having any doubts to go further. If you clarify your doubts, right, further story becomes so easy. If you clarify your doubts now, further story becomes so easy. If you clarify your doubts now, further story becomes so easy. So easy. Further story becomes so easy if you clarify now itself. L1 is equal to A power n, where n is greater than or equal to 1. Single A, double A, triple A, 4 A's, and so on. Check everyone. Check everyone. Yeah, if you don't have any doubts, let's move to next. For the formal language L1, right, I created the finite automata. Finite automata is nothing but collection of states, nothing there. Finite automata is nothing but collection of states. Simply collection of states. Right? Now see the next one. One more formal language I will take, because I cannot draw everything here. It will confuse you. Because of its introduction, let me write whatever is really required. Right? Further, anyhow, 30 problems we will discuss. Further, anyhow, we'll discuss 30 problems. As of now, introduction, only my required things I will take. Right? L1 I done. So I will concentrate some other language now. Let's go for L4. A power and B power n. Let's go to L4. Careful everyone. L4. L1 purpose I done. Let's take the L4. L4 is equal to A power n, B power n, n greater than or equal to 1. Let's go to L4. L4 is equal to A power n, B power n, where n is greater than or equal to 1. Sir, finite automata or any automata is a collection of states, of course. When you say some more machines, when you say some more machine, maybe something extra also there. Not only collection of states, something extra there. You will get to know. Right? Finite automata is a collection of states. What about other machines? You will see. You will see within few minutes. Sunny, please control yourself. Whatever you are asking, sir, finite automata or any automata is a collection of state. True. But other automatas are having not only state, something extra also. Something extra also. Just wait a few more minutes, you will get the total story. It is something like you married, you just married today morning, right? You don't get right afternoon kit. Today morning, just you married, just relax, have fun, just relax, have fun, right? Morning you married, just relax, have fun. Maybe after 1 year, that 1 year down the line, you will get the kid. You cannot ask afternoon itself, where is my kid? You cannot ask evening itself, where is my kid? So you will get to know within few minutes. You will get to know. Sunny, have some patience. Have some patience. Don't kill partner. Where is my kid? Where is my kid at 12 o'clock? Don't ask like this. I'm not married. Okay, good boy. Good boy. Good boy. See this one. L4 is equal to a power and b power, and where n is greater than or equal to 1. Now observe here. If you see the strings of this language, n is equal to 1, AB, n is equal to 2, double A, double B, n is equal to 3, triple A, triple B, n is equal to 4, 4 A's, 4 B's, n is equal to 5, 5 A's, 5 B's. If you observe clearly, right, number of A's is equal to number of B's. Number of A's is equal to number of B's. In this language, if you observe clearly, right, number of A's equal to number of B's. Number of A's equal to number of B's. Right? Now observe. Observe everyone. Everyone observe. You draw finite automata whatever way you like. Problem will come. So let us assume some people are asking, sir, can you create the finite automata? It's not possible. Because you have to count number of A's also, number of B's also. How many A's happened, how many B's happened. You have to check both are equal or not. Only finite automata you cannot handle. Some people are asking, sir, why can't I handle, sir? Let's check. Why can't I handle? Can you see this one? Some people are asking, sir, why can't I handle, sir? Can you see this one? 1A, it is a starting state. Assume it is final state. 1A followed by any number of A's. 1B followed by any number of B's. If you observe clearly, this is the S1 state, this is the S2 state, this is the S3 state. S1 state, S2 state, S3 state. S1 state, S2 state, S3 state. If you observe clearly, this automata is accepting single A, single B. How? Start from starting state. S1 on A, S2. S1 on A, S2. S2 on B, S2 on B, S3. So single AB accepted. What is the meaning of accepting? After that string is over, are you in final? After that string is over, are you in final? Remember, according to this language, according to the given language, right? AB is a member. AB is a one of the member in this language. Is it accepting? Yes, happy. Next one. Is double A, double B accepting? Let's check. Single A, always you have to start from starting state. Single A followed by one more A, one time. Single B followed by one more B, one more time. So AB also accepted. Start always from starting state. At the end of the string, where are you? Are you in final? So string is accepted. So single AB accepted, double A, double B also accepted. But problem, see the problem. The problem with this machine, the problem is going to be, see this one, the problem is A triple B also accepted. A triple B also accepted. How? Single A from S1, single A, you will come to S2. On S2, single B, I will goes to here. Any number of B's also I can accept. It is also accepting, but in our language, single A, triple B not available. Check. According to our language, number of A's equal to number of B's. It is also accepting, but which is wrong. Valid thing accepting, okay, it is a valid accepted, no problem. It is also valid accepted, no problem. It is invalid but still accepting. Invalid string accepting. Invalid string accepting. Invalid string accepting, that is the reason it is wrong. Invalid string it is accepting, that is the reason it is wrong. So L4 is a formal language where finite automata cannot work. Finite automata not possible, because you write any finite automata, it will create the problem. Some problem will come. You draw any finite automata, sir, how to draw finite automata? I am not getting. You will get afterwards. It is the introduction. Please understand the terminology. Please understand the terminology. Oh, finite automata, collection of states. Finite automata, collection of states. Finite automata is a collection of states. Right? So some people are asking, sir, what is the meaning of accepting? At the end of the string, you should be in the final. Sir, from where I can start the giving the string? Start from starting state. Start from starting state at the end of the string, not in the middle, not in the starting. At the end of the string, where are you? You started from starting state. At the end of the string, where are you? Are you in final? String accepted. Are you in non-final? String rejected. A, B accepted. Double A, double B accepted. The single A, triple B also accepted, which is invalid. So valid accepting, no problem. Valid string accept. Valid string accept, no problem. Right? Valid string no. It is not valid string, but still you are accepting. So invalid string you are accepting. That is the reason this automata is wrong. If you want to know something is wrong, if you want to know some automata is wrong or not, this is the way of checking. One invalid also cannot accept. One valid also cannot miss. It is an invalid string. It is an invalid string, but accepting. Invalid accepting means rejected. So let me write now. I will write here itself. I will write here itself. Automata is correct. Automata is correct. If you draw the automata is correct when automata is correct when, see the first condition. Every valid string should accept. 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 Second one, every invalid should reject. Every invalid should reject. Every valid should accept. Every invalid string should reject. Then only automata correct. Then only automata correct. One invalid also accepting, your automata wrong. One valid also missing, your automata is wrong. So finally, to solve the L4, finite automata is not possible. So some people are asking, because the finite automata fail, what should I do, sir? You have to go for, right? To accept L4, go more than finite automata. L4, let me write here. Let me write here. L4 finite automata not possible. L4 finite automata not possible. Then go more powerful machine than L4, which is the PDA. Just go to PDA. Just go to PDA. L4 finite automata fail. Then go to PDA. Some people are asking, sir, what is PDA, sir? What is PDA, sir? Nothing. PDA is nothing, but you can use as usual whatever finite automata you are using. Use as it is. Means states also there. States also there. What is the PDA, sir? Very simple. Whatever finite automata you are using, use same finite automata, no problem. Plus, use one stack also. Use one stack also. Finite automata plus one stack is nothing but PDA. L4 finite automata saying no, I cannot. So more than finite automata, little powerful is PDA. Little powerful is PDA. What is PDA, sir? Finite automata plus one stack. So in the L4 also, sorry, in the PDA also, there are states. Because of finite automata, there are states. Plus one stack also there. But major one is stack. PDA means major one is stack only. But remember, finite automata plus one stack. Finite automata plus one stack is called PDA. Some people are asking, sir, using PDA, how you solve L4? Let me write now. What is L4? L4 is equal to A power n, B power n, where n is greater than or equal to 1. It's a L4. If you see the strings, valid strings, single A, single B, double A, double B, triple A, triple B, triple A, triple B, and so on, and so on. Number of A's equal to number of B's. Number of A's equal to number of B's. Not only that, A's should come first. 1A, 1B, 2 A's, 2 B's, 3 A's, 3 B's. This is the automata, right? So this is the language. We have to construct a PDA. PDA contain finite automata also there, stack also there. I cannot write everything, just I am giving some idea. Everyone can understand how to construct a PDA for this. Very simple. PDA contain one stack. Now listen. Now listen everyone. Now listen everyone. Roughly I am giving. In the PDA construction, there is a one chapter is the PDA construction. There is a one chapter PDA construction. There we are going to discuss 20 problem we are going to discuss. Finite automata 30 problems we'll discuss. PDA will discuss 10 problem because right it is also contain finite automata. PDA also contain finite automata plus some one stack extra. For that purpose we will do 10 problems. Turing mission also we will do. For that purpose we may do 5 problems. Right? Previously 20, initially finite automata having more weightage, 30 problem. PDA having next lesser weightage, 20 problem. Turing mission maybe 10 problem. Like that we will do. So that everything is okay. I will do approximately from my side 60 to 70 problem. You do from your side one more 60 to 70 problem. Almost TOC over. So TOC is the easy subject where you will get the marks in the examination very easily. Right? Now come here. How to solve this problem using stack, sir? Listen, let us assume that bottom of the stack initially, assume dollar symbol, some marker. You keep any marker. Bottom of the stack is dollar. Remember, stack contain dollar means empty. Stack contain dollar means empty. Stack contain dollar means empty. Remember. Now see what happened. Right? Stack contain dollar means empty. Now what you do is on this dollar, everyone listen. On this dollar, if A coming, in the input A coming, in the input string, A is coming, push. Again A coming, push. Again A coming, push. If A's are coming, push. In the input string, A is coming, push. Let us assume that my input string, let us assume 5 A's, 5 B's. My input string is 5 A's, 5 B's is coming. 5 A's, 5 B's are coming. My input string is 5 A's, 5 B's are coming. Lastly, followed by some dollar. Assume that every string having end marker also. Otherwise, how I know string is over? Every string having some end marker also. 5 A's, 5 B's. See that story. A coming, push. A is coming, push. When you say stack, you have two operations, push or pop. Right? A coming, push. A coming, push. A coming, push. A is coming, push. So 5 A's are pushed. Now, after completion of A's, the stack contain dollar already at the bottom. 5 A's are pushed. A coming, push. A is coming, push. A is coming, push. Like that you do. Because in our string, A's, right? If you see our language, A's coming first. A's coming, push. A's coming, push. A's coming, push, like that. Because in our string, A's are coming first. A is coming, push. A is coming, push. A is coming, push. Like that, you will keep on push. Okay, fine. Right? Now people are saying, sir, now B's are started coming. What should I do? Can you see this one? B started coming. Now B's are started coming. Everyone observe. Everyone observe. B coming. B is coming. Top of the stack is A. Pop. B is coming. Top of the stack is A. Pop. Right. Next one. B coming. Top of the stack is A. Pop. B coming. Top of the stack is A. Pop. B is coming. Top of the stack is A. Pop. B. Right. So I think after completion of this, if you see the diagram, dollar will be there. A will be there, A will be there, A will be there, A will be there. Now see the answer. 5 A's. 5 A's, right? 5 A's. Now if you see the input string, 5 A's, 5 B's. This is the input string. Already in the input string, 5 A's, 5 B's already. A's are completed. Now see some 4 B's. B coming, top of the stack is A pop. B coming, top of the stack is A pop. See, B coming, top of the stack A pop. 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 B coming, right? Until now, this is the story. Now, if you see the diagram properly, still dollar there, still one more A there, because totally you got 5 A's, 5 B's, right? Until now only 4 B's. Now see this one. Now again, if B coming, top of the stack is A pop. B top of the stack is A pop. Okay, you done that also. Then it will leads to dollar here, right? Like this. Now observe what is the input. If you observe, 5 A's over 5 B's also over, 5 B's also over. So for every B, A cancel. 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 If you observe clearly, string over, dollar will come. See, dollar is coming, top of the stack also dollar. That means A's and B's both cancel. So let me write now. If input dollar is coming, if input dollar is coming, and top of the stack also dollar. If input is dollar is coming, if input dollar is coming, and top of the stack also dollar, that means for every B, A is cancelled. For every B, A is cancelled. Suppose isn't that right? Next input coming is dollar, top of the stack is A. That means some A's are still left out, B's are less. Suppose next input coming is a dollar, top of the stack is A, A's are more. Suppose next input coming is B, top of the stack is a dollar, means B's more. B's more, right? Whenever B coming, top of the stack is no one, B's more. Whenever dollar is coming, top of the stack is A, A's more. But the thing what happening is dollar is coming, top of the stack is dollar. That means for every B, A is cancelled. That means for each B, A is cancelled. One A is cancelled. One A is popped. That means for each B, one A is popped. That means number of A's is equal to number of B's, which is equal to number of A's is equal to number of B's. If input dollar is coming, top of the stack is also dollar. That means for each B, one A is popped. That means number of A's equal to number of B's. Yeah, you will get to know. Are you comfortable till now? L4. See this one, the total discussion. Very simple. Don't make it complex. Very simple. You may not get everything. I am very sure you may not get. Because it is the introduction class. You don't get. Roughly, what is PDA? I want to say to you. PDA contain one stack. Understand, you cannot get everything. Don't try to get everything in one day. It is not possible. There are some people, they will go to barbecue. They want to eat everything in one day. You will get stomach pain. You will get the food poisoning. There are some people, they will go to barbecue nation or barbecue, they will go. They want to eat every day, everything one day. You will get the stomach pain. You will get the food poisoning. Same thing here also. Don't try to get everything here. Just understand what is going on. It will take few days, right? So if at all that much easy, in one class I will complete TOC. If it is that much easy, I will complete TOC in one class. Let's enjoy like a movie. Let's enjoy something like character introduction is going on. Is the hero some introduction? Is the heroine some introduction? Right? Villain some introduction. Some introduction is going on. So PDA purpose some introduction. L4 cannot accepted by finite automata. L4 will be accepted by PDA. First of all, what is PDA? Finite automata plus one stack. It is also having states. One stack. So if from today onwards, if anyone asks you, can you construct a PDA for the given problem? I will give one problem. Can you construct a PDA? Very simple. Can you solve that problem with one stack or not? Check. Here I have to compare number of A's equal to number of B's. Here I have to compare number of A's equal to number of B's. Some people are asking, sir, how to compare, sir? When A is coming, push in the stack. Because you have to compare with B's. Whenever A's are coming, push in the stack. Whenever B's are coming, for every B, pop one A. For every B, don't pop many. For every B, pop one A. Can you see this one? B coming, top of the stack is A, pop. B coming, top of the stack is A, pop. This is the way how comparison is done. See, for each B, one A, pop. 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 Lastly, after completion of this one, 4 A's, 4 B's are cancelled. Lastly, 1 A, 1 B left out. So, for that B, 1 A popped. Now, stack contain nothing. Input also contain nothing. So, if dollar is coming, top of the stack also dollar. That means for each B, 1 A is popped. That means number of A's equal to number of B's. Are you okay? That means number of A's equal to number of B's. Are you comfortable? Are you comfortable? That means number of A's equal to number of B's. Are you comfortable? Simple. PDA. Sir, PDA means what? PDA contains stack. Sir, PDA contains finite automata also? Of course. Bigger machine contains smaller machine also. Bigger machine contains smaller machine also. Finite automata is smaller. Bigger machine is PDA. Bigger machines can handle smaller machine also, because bigger machine inside having smaller machine also. Let's see the example. Calculator and computer. Whatever that calculator can do something. Computer can do something. But if you observe clearly, whatever calculator can do, computer also can do. Comparing the calculator, computer is a bigger machine. So calculator having keyboard, yes, computer also having. Calculator can do calculation, computer also can do. Right? Bigger machine contains smaller machine also. Finite automata, PDA contain finite automata also. That means whatever finite automata can do, PDA also can do. But finite automata don't have stack. Remember, this problem can be solved. Use stack required. To solve this problem, stack required. Finite automata don't have stack. Without stack, this problem cannot be done. Without stack, this problem cannot be done. So PDA contains stack also, finite automata also. Remember, PDA already contain finite automata. Whatever finite automata accepting, he will also accept. See, he also having finite automata. PDA also having finite automata. Whatever finite automata can accept, PDA also can accept. But because of this stack, PDA accepting little more. PDA accepting little more. One example, right? A power n, B power n. Number of A's equal to number of B's. Number of A's equal to number of B's. Okay. Right? Now understand. Everyone understand. I think right, Kya Feida. His name is Kya Feida. His name is Kya Faida, is asking one thing. Sir, number of A is equal to number of B's you want to compare. Number of A is equal to number of B's you want to compare, but it is a finite language. Number of A is equal to number of B's you want to compare, but it is a finite language. Then how it is regular, sir? Somewhere he studied, even though comparison is there. If it is a finite language, it is a regular. Somewhere he studied. So he's saying how it is possible. Let's check. See this one. Let's check here. Actually, it is not there in our story, but because of Kya Faida is asking, only for namesake I'm saying. Listen everyone. Let us assume that one formal language L10. Everyone listen. Let us assume that one formal language L10. Everyone observe. Let us assume one formal language L10. Right? See what happened. L10. If I talk more, people will confuse. That is the reason I don't want to say all these things, because anyhow they will come in further classes. But Kya Faida is asking something, and I'm clarifying here. So this one I'm clarifying. Kya Faida is asking some small thing. I'm going to clarify. Can you see this one? L10 is equal to A power n B power n, where n is, careful everyone, where n is minimum is 1, maximum, let us assume, maximum 2. So I want to say it is a formal language, but finite formal language. It is a formal language, but finite formal language. So if you see the strings here, you can compare. Right? Because of A power and B power, and you have to compare. Number of A's, number of B's, you have to compare. But it is a finite language. Right? So it is a single A, single B, double A, double B. Single A, single B, double A, double B. It's a formal language, but a finite formal language. So, sir, how to handle? Now listen everyone. S1 state, starting state S1, observe everyone. So if I say more, you may be confused. That is the reason I'm not saying, but someone asking, just I'm giving some idea. Don't worry. AB. On S1, AB, go to final. On S1, AB, go to final. Okay. Now see the answer. On S1A, go to S2. On S2B, go to S3. So this is accepted. Now see the answer. On right? S1A come to S2. S2A come to here. B come to here. One more B. Go to here. So if you observe clearly, double A, double B also, you can go to final. Please check. On S1, AB also you can go to final. On S1, double A, double B also you can go to final. Double A, double B also you can go to final. Understand this. So for every finite language, finite automata possible. With the states you can manage. Even though number of A's, number of B's you want to compare, still possible if it is a finite language. If it is a finite language, right? Finite automata can do that. Finite automata saying that I have finite number of states. Using those states, I can manage finite things. Finite automata saying that even though comparison is there, see, number of A's equal to number of B's I want to compare. Even though comparison there, still I can do if it is a finite language, because I have finite states. So remember, even though comparisons there, still finite automata possible. Normally comparison means finite automata cannot. Still finite automata possible. If comparison there, finite automata gone. So I'm writing here, see, comparison, finite automata gone. Comparison means finite automata gone. Comparison there, still finite automata possible. What is the reason? Reason is it is a finite language. It is a finite language. Finite language means finite automata saying that because of it is a finite language, I have finite states, I can handle. It is finite language. That is the reason. Thank you so much. For asking. L10, if you observe clearly, number of A's, number of B's, you have to compare. Whenever you say compare, whenever you say comparison, finite automata cannot be possible. Even though comparison there, even though comparisons there, still finite automata possible because it is finite language. Because it is finite language, it's a very, very important one. Anyhow, it will come. Someone asked me now. That is the reason I clarified. So I'm again reiterating. You may not get everything. Try to get as much as possible in the first two classes. Last class, this class purpose, understanding introduction of automata. Introduction of automata. So the first question people are asking, sir, these many automatas, why, sir? Ready, sir? Why these many automatas? Many people are asking, why these many automatas is the reason why these many automata. You only say, why these many machine? Calculator is there, why computer? Calculator is there, why computer? Computer is there, why something else? So everything will do some work. Everything will do some work. So if you want to do more work, bigger machine you have to go. If you want to do complex work, bigger machine you have to go. So L1, fine. Listen, if you can check this, if you can check this one, right? If you can check this one, L1, finite automata is possible because no comparison is there. In the L1, no comparison because only one person. Where is the comparison? Only A's are there with whom you will compare. So L1, no comparison, finite automata possible. L4, comparison there. See, A's and B's you have to compare. Comparison there, finite automata failed. Comparison means finite automata gone. Comparison, finite automata gone. Next one, automata, right? Some people are asking, sir, when can I say automata is correct? If you want to say automata correct for a given, every valid string should accept, every invalid should reject. Next one, sir, can you draw for L4 finite automata not possible? Okay, because of comparison, right? Can you do PDA? Remember, PDA is nothing but finite automata plus one stack. PDA contain finite automata also, PDA contains stack also. But here in the L4, comparisons required. Comparison means stack required. Comparison means stack required. Comparison, stack required. Stack required. So L4 contain comparison. Finite automata saying I cannot. I have stack also, I have finite automata also, I can handle. So finite automata plus one stack is called PDA. So some people are asking, sir, what is the logic here? So you have to solve this problem using one stack. How? A's are coming, push. Very simple. A's coming, push. B's coming, pop. Whenever B's over, right? I think A's also over, then everything is fine. See, if input is dollar, means string is over. If input is a dollar is coming, that means A is also over. Input string dollar coming means B is over. Top of the stack is also dollar, yes over. For every B, A cancel. For every B, A cancel. Then when I say B is over, then he's saying A is also over. Means for each B, A is popped. Number of A's equal to number of B's. So immediately someone is asking, sir, A power and B power and comparison there. But it is a finite language. A power and B power n, right? You have to compare number of A's equal to number of B's. But comparison is there, how PDA? But it is a finite language. Finite language means finite automata saying that, see, even though comparison is there, still finite automata possible because it is a finite language. With the help of finite states, you can manage it. It is possible. So double A, double B. If you want, you can check. Don't think much. Don't think much, you will confuse. See this one. Double A, double B. I start. Am I reached finally final state by reading double A, double B? Yes, it is accepted. I started from starting state by reading single A, single B. You reached final state? Yes. You may not get it. You may not get complete diagram. You may not get complete diagram. Please be careful. So you have to understand only one thing. Even though comparison there, normally comparison means finite automata gone. Even though comparison there, finite automata sometimes pass. If language is finite. If language is finite, even though comparison is there, finite automata still work. I hope everyone got it. Right? Fine. Is it okay? Is it okay? Now what you do is in the tomorrow's class you will see, in the tomorrow's class you will see, in the tomorrow's class you see what is the language. Let me write the language name. Let me write the language name. In the tomorrow's class is L5, A power n, B power n, C power n. In tomorrow's class we will see L5. Yeah, so L5 purpose, L5, which is A power n, B power n, C power n, A power n, B power n, C power n, where n is greater than or equal to 1. A power n, B power n, C power n, where n is greater than or equal to 1. A power n, B power n, C power n is greater than. Remember here comparison there. Finite automata gone. So PDA, you check PDA. You check PDA. PDA contains stack. You check PDA. This is your homework. Tomorrow's class, as soon as I will start, I will give. PDA check. PDA check. In tomorrow's class, I will give. And one more thing. If anyone, if you serious about GATE examination, if you not join, please go and, because after few classes, classes will be there in the exam prep tool. Every class is 2 to 3 hours. Go to exam prep tool, you can join. Use the code EPT. Use the code EPT 610 EPT. You will get the 50% discount. You will get the 50% discount. It may be vanish very soon. Use the code EPT 610 EPT. 50% discount is going on. In the EPT, every class will be 2 to 3 hours. Minimum 2 hours will be there. And the EPT, every class, minimum 2 hours, 2 to 3 hours. Sometimes class may be 4 hours also. So that syllabus will be over faster. Morning class, morning algorithm is, right? Morning TOC going on, evening algorithm going on. Evening algorithm is going on. Please join both. Morning TOC going on, evening algorithm is going on. Join both the classes. Join both. Right. So if you have any small doubt also, right, you can WhatsApp us. We are going to help you. Okay, fine. Thank you so much. See you in the next class. Thanks. These notes will be shared in the group. If you are not joined in the group, join the group. If you not join the group, join the group. If anyone not joined the group, please join the group. These notes will be shared in the group. These total notes will be shared in the group. If anyone not joined, join the group. Right? Fine. It is a lecture number 2. Right. Thanks everyone. Thank you so much.